This is the 3-minute summary of my video on writing to flash on the Pico when using FreeRTOS and FreeRTOS SMP, running dual core. Hi, I'm John, your concierge to the world of Raspberry Pi Pico, IoT, robotics and other fun tech. I did a previous video on non-volatile storage or writing to flash on the Raspberry Pi Pico. I demonstrated flash in bare metal for single core and dual core firmware. Take a look at that video on how to write to flash on the Pico. All the code for working with flash as non-volatile storage in bare metal and FreeRTOS versions is on GitHub. I've built this as a library, example and unit tests. The library stores name value pairs and writes these to the flash when a commit is called. In FreeRTOS, we need to work with FreeRTOS kernel services to create a critical section within which we can write to the flash. In single core mode for a Pico, this is really simple because we just use the task enter critical and task exit critical macros. This will prevent the task being interrupted in the critical section and no other task will be able to run. Therefore, nothing will try to read from the flash while the write cycle is running. To do the same thing in FreeRTOS kernel SMP is more challenging. Both cores are reading instructions from the flash, and that includes FreeRTOS scheduler code. So even if we stop all of the tasks that could be running on core 1, we'll still have idle running on core 1. That will be enough to break the flash write process and cause the processor to panic. What we need to do is cause core 1 to only run functions from memory during the flash write cycle. We can do that using the not in flash function macro. So my solution is to allow me to write my MVS data to flash is to take complete control of the two cores, to use core 0 to manage the process and to write to flash, to use core 1 to enter a pause state running code that is only in memory. I trigger both of these tasks to begin the cycle using the task notification FreeRTOS messaging. During the critical section, I also need to get some status and ask core 1 to resume. I can't use notifications for that without running FreeRTOS code, which would be pulled from flash. Therefore, I use a simplistic Boolean as a semaphore between the two tasks. Because they are single byte writes and only one task writes to each Boolean, this is safe. When using FreeRTOS SMP, I need to not use my MVS onboard commit method, but instead start the MVS agent, then call the MVS agent commit function. Running this through my unit test shows it works nicely with background tasks to challenge the code. FreeRTOS single core writing to flash is trivial, but in SMP mode, due to the way that flash works on the Pico, this is challenging. My strategy is to take complete control of the two cores to prevent any fighting over the flash. I would not say this was an elegant solution though, but the only one I can come up with. Do you have a better suggestion? Let me know in the comments. Thank you very much for watching. Please like the video as it helps encourage me to make more videos, and please subscribe and hit that notification button to avoid missing the next video. Goodbye for now.